Hello, my friends. Welcome to Ask the Expert on Learn TV, the show where you can connect directly with the experts to get your questions answered live. Today, we're talking about what's new with Azure Machine Learning, and I've got a set of wonderful guests with us. They didn't tell me to start, but my face is here, so I'm going to start. So up at the top over here, we have Rupe. There he is. And then I'm going to have them introduce themselves. They go, Rupe, tell us who you are and what you do and what kind of questions they can ask you.
Okay, so I'm Roope. I'm a program manager in the Azure ML team, and I can answer questions about enterprise readiness, security, privacy in Azure Machine Learning.
So I've been saying it wrong. It's Rupe. Roll that R's. Anitha over here. Why don't you introduce yourself? Tell us who you are and what you do. Right here.
Hi, everyone. I'm Anitha. I'm a program manager on the Azure Machine Learning team, specifically focused on many models and AutoML. So if you have any questions about many models and AutoML, bring it my way.
Fantastic. And then right over here, Saudia.
Hi, everyone. My name is Saurya Das. I'm a product manager in the Azure Machine Learning team. I focus on the hybrid strategy, including, with Kubernetes, including AKS and Azure Arc for Kubernetes.
Fancy. Right over here, we have my friend, Marnoush.
Hi, everyone. My name is Marnoush Simeki. I'm a program manager in the Responsible AI tooling team. I work on machine learning interpretability, fairness, assessment, unfairness mitigation, and error analysis. So if you have any questions about how to make sure that your models are developed and deployed in a responsible manner, bring it my way.
Fantastic. And then right over... Hold on, I'm waiting for the switch. There you go. Right over here, we have Sam.
Hi, I'm Sam Kemp. I'm a program manager on the Azure Machine Learning team. I focus on end-to-end experiences, so you can sort of ask me questions around like the notebooks, experience VS Code, integrations, and those sorts of things.
Fantastic. So to get the pump primed, I thought I would start with a basic question that probably everyone is wondering about, which is this. What is the purpose of Azure Machine Learning? And because I just learned how to say his name correctly, Rupe, will you start with us, my friend? What's the purpose of Azure Machine Learning, and why should people think about using it?
Oh, okay. So the purpose of the Azure Machine Learning is to make data science, machine learning available, easy to use for different enterprises, different users at different skill levels, starting from code to notebooks to no code experiences. We also want to make sure is that when people do machine learning, when they do modeling work with data, they can do it in a secure and trustworthy manner that respects the policies of their enterprise.
So basically, Azure Machine Learning empowers data scientists, developers to build their own artisanal, free-range, organic models. Am I getting that right?
That is exactly right.
Fantastic. So we'll go to you, Anitha. Why don't you explain, because maybe someone's watching that are like, I've heard what an AI model is, but what does that mean in the context of a programmer and how Azure Machine Learning helps? Because you do many model stuff. What does it mean to have what is a machine learning model?
Cool. Yeah. So, within Azure Machine Learning, we have several ways for you to build your models, let it be using automated ML, or you could just bring in your custom script. Now, when it comes to many models, we've heard from our customers where they want to build multiple models, because in real life scenarios, within machine learning can be complicated. It can't be just simple as solved in one single model. So that's why we have our many model solution accelerator, which helps you build, let it be tens, hundreds, thousands, or even millions of models.
But what is a model? Like, let's just say I'm a complete noob. Pretend I don't know anything. She's like, done. So easy. What is a machine learning model even? What does that even mean? Like, we talk about AI and it feels a little like foggy. And so I think maybe people have a hard time understanding, like, what are we even building, Anitha?
So yeah, a model contains what is an algorithm. You're bringing in your data set, you're going to tune your hyperparameters, and then it's going to bring you a model which helps you identify if this is the best way to optimize in a scenario. So it's helping you solve a machine learning problem with a model, basically. So,
I see. So it sounds like it's a lazy way of writing programs with data. Did I get that right?
sounds good. About right to me.
Every time I say that, people are like, wait, what? I thought it was like robots and stuff. Saudia, when it comes to building machine learning models, it turns out that you need a lot of hardware. The first question I have for you is why? And the second question I have for you is, how does AML help?
Yeah, when it comes to hardware or infrastructure, there are different kinds of machine learning models. There are different kinds of frameworks, and they are suited to particular kinds of hardware, like some CPU optimized, some GPU optimized. In GPU, you have different categories of GPUs. So all that variety is what you get in the cloud. It's hard for you to have that all in the infrastructure, and that is what we are trying to learn from customers. So what are some of the common patterns we are seeing when it comes to hardware usage and frameworks? The kind of jobs that they can run, whether it is a single node job or a multi-node job, how to make it efficient. And it's just not compute. It's also got to do with networking, how multi-node jobs talk to each other when multiple jobs are running on each of these nodes. So it's quite complex, and we are trying to learn and try to offer guidance to customers on that. Does that make sense? Does it answer your question?
I think so. And then the other question is why do we need so much hardware to build these models? What is it about making these models actually do the right thing that makes it require all this infrastructure?
Yeah. So yeah, when you want to write a model, you get it more accurate if you have large amounts of data. So large amounts of data processing requires large amount of compute infrastructure. There's also the computational aspect of it. The computational aspect of processing so much data and then trying to build models again requires large swaths of machines. So that is where the requirement for large infrastructure comes into picture.
I see. And why GPUs in particular, if I may ask?
Yeah, GPUs specifically have these capabilities of doing computational of like millions of transactions per second. They are faster, bigger, so they can do jobs, run jobs, or perform computation way faster and at a larger scale than CPUs. That's mostly about it.
I love that, and because it's all in the matrix. It turns out that GPUs are really good at doing matrix multiplication, which is basically the foundation of all this stuff. So when you're playing your games and you're like, wow, this looks so cool, it's because it's multiplying matrices. And that's what machine learning is, right? It's just a bunch of matrices that you multiply. But it turns out because... Sorry, Saudia, you were saying?
Lots of mathematical computations, like transformations on matrices, like you said, multiplications, they are computation heavy.
Yeah, and it turns out that you're doing the same function on like millions and millions of things, and GPUs can do them all at the same time, which is nice. And so building them on these huge hardware devices makes it a lot easier, but it doesn't really help us with understanding what the model learned. Marnoosh, can you talk about the responsibility of folks when they build these things with this huge hardware? They're building many millions of models, as Anita said, and as Rupe explained, AML helps. What is our responsibility as practitioners when it comes to building these models?
That is a very good question. So I actually remember those days where people were training complicated models and they were actually taking a lot of pride in it, that, wow, I have designed and developed and trained a model that I have no idea about. And it's so cool and can do the magic and provide me with answers. Not anymore, let me tell you that. So we now all understand that there is a lot of responsibility in what we are putting out there, because that can have direct impact on humans' lives. What resources, opportunities, information they're getting, what quality of service they're getting from the model. And so given that high-stakes scenarios that AI and machine learning is involved in, it is super important for our models to be understandable, for us to understand how those models have made its predictions, what factors of that individual or overall, what features they're using in order to say reject a loan or approve a loan, or what factors of this patient they have used to predict that person as a high risk for a specific disease, and so expand it to other use cases as well. And so that's why it is very important for us to tools and solutions for you out there to help you understand how your model has made its predictions. So we call them machine learning interpretability toolkits. We have great offerings in the open source integrated within Azure Machine Learning. And we have a set of fairness assessment metrics, APIs, and also unfairness mitigation algorithms for those use cases that you might have where fairness can be an issue. And similarly, they're also open source and integrated within Azure Machine Learning. And eventually, we just announced a toolkit for helping you on analyzing and understanding where errors are laser focused in subsets and cohorts of your data, where you can use as your first step to identify how errors are happening inside your model and hopefully have a game plan to diagnose it with interpretability and mitigate it with a variety of different techniques.
So one of the interesting things, Marnoosh, and we'll stay with you, is that it didn't occur to me when I was first building machine learning models, 17,000 years ago, that these things can actually cause harm. But it's even more than that. If you subdivide the harm that it can do, there's a lot of study that's gone into that. Marnoosh, can you speak to that a little bit?
Yes. So there are multiple different types of harms that can occur on people and different types of errors that can happen in real world when you use machine learning. There are, of course, fairness issues. As I said, harm of allocation, how resource information and opportunities are allocated. Harm of quality of service, what type of quality of service variety of different people are getting from the model. But also, besides fairness issues, there are just regular issues that can happen. There can be reliability issues that, for instance, your machine learning model is not performing well when the weather is rainy or foggy. You really want to know that corner case, which makes your machine learning fail. Otherwise, it's going to fail in a real world scenario. It's going to embarrass your company because the solution was not able to handle corner cases. But without such tools, you don't have an understanding. And then the third aspect is just like errors that can lead to trust issues. For instance, you go to a grocery shop, then your model is working well on, say, detecting an apple and saying how much that apple would cost per pound, but is not doing as well for another type of fruit. So then if you see such an issue, you as the user will lose your trust of using this model anyways, because you know it's not going to do well across the board. So it is super important to detect all these different types of issues and have mitigations around it to improve the model.
That's cool. And so we're going to come to Sam next, but before we do, just everyone get ready, because the next question for every one of y'all, because you've noticed that I've gone, 1, 2, 3, 4, 5, right? The next question is, what are some features in Azure Machine Learning that are new since Ignite or that you feel aren't talked about enough that you want to get folks to know about? So get ready for that. Sam, as we've been talking with Marnoosh, it feels to me like all of a sudden this becomes a lot of like standard software development, but with a lot of data. Can you speak to how Azure Machine Learning helps with the standard practice of building these things? And I'm thinking in terms of, I've heard this term ML ops. Maybe you can help us with that.
Yeah, so for me, is ML ops like a way of life, etc.? Really, the way to think about it is like in software where you are building that software and deploying that software out like an application. Machine learning is very similar in many respects. We have to retrain the model. We have to then, once we've built that model, test the code as well. Is the code quality good? We have to deploy that out. And so ML ops is really sort of inspired from this DevOps process, but it's more specific to the machine learning cases. So some specific things around that we do in Azure Machine Learning is integrating into Azure DevOps, for example, so that people can access their workspace from that and start to say, right, hey, go run this training job on when I've do a code push, right? Go rerun that training job, spin up the whole environment from scratch. And these are the sorts of integrations that we brought into the product.
And so how does Azure Machine, like, for example, like when I build stuff, there's always this notion of, I used to be a .NET programmer for many years, right, in my former life. And there was always, when I did my, regular ops, DevOps, there would always be this process of building artifacts and seeing them through, shepherding them through a process. Is that similar, would you say, in machine learning and ML ops, Sam?
Yeah, absolutely. So machine learning has artifacts as well. So when we train a model, for example, the artifact that comes out of that is actually like a binary object, and so we want to track that binary object. And that binary object is really coming back to your point about matrices, right? That binary object is normally storing things like weights and the kind of compute graph around that. And so we get those kind of artifacts. Other types of artifacts that we can get from machine learning are data artifacts as well. And that's something that is potentially different to applications. And so we have to track data assets through that life cycle too.
This is cool. So, by the way, if those that are watching on Learn TV, I will hog these people all day because they are amazing. But please, your questions are super important to us. We're going to start. So please get those questions in. I'm starting to see some of them. Let's start at the top. Rupe. Is it? No, say it again. I want to say it right.
It's rope.
Rope. Nice. See, because I'm Hispanic, we know how to roll our R's. Rope. Let's talk about AML, number one. What are some exciting features that you think everyone should know about, or that are new, or maybe that you just like people don't talk about enough?
Oh, okay. Let me talk about some new features that we've kind of like done in my field, the enterprise readiness. So one area where we've invested quite a lot is it's like the identity management and access control. So it used to be that if you started using Azure Machine Learning, what you do first is you create something called a workspace, which is as a resource where you do your machine learning work. You have things like compute resources there. You have data sets. You have data stores, and that's also where you keep your models and things like that. And the problem used to be that we would only give you kind of like a one tier of access to the workspace, which is something called contributor, which is basically Azure parlance for super user. So basically, in the past, if you wanted to do work in your machine learning workspace, you had to be a contributor, and you had super user access to create, delete computes, run over your quotas, delete data sets, do things like that. You have to be a bit careful about. So to kind of fix that situation, we've added something called RBAC roles. RBAC stands for role-based access control, which means now let's say you are a data scientist and need more limited access to the workspace. You might want to be able to train models, but you don't necessarily need to scale up and down your compute resources, so you shouldn't be able to delete data sets. So with these RBAC roles, you can customize the level of access to your machine learning workspace that's suitable for data scientists, data engineers, MLOps personas who deploy models to production, so that everyone has the access they require, but no more. We've also added features around network security. Basically, what we've added support for is something called private link or private endpoints. Which is a capability that let's say you don't want to expose your data sets to a public internet, or you don't want to expose the Azure Container Registry where you keep your Docker images used to running your training code. You don't want to expose that to public internet. What you can do now is basically build a layer of isolation around your machine learning workspace, around these associated resources, so that they are not visible to the public internet, and only users who have access inside the VNet, either through a specific VM or through an or through a VPN connection, can use that workspace, which adds another layer of security that's very important for many of our enterprise customers.
I mean, that's really cool. Basically, fine-grained role-based access control as well as VNet support, so that there's really no exposure to anything. Because sometimes the data can be quite sensitive that people are doing machine learning models over. So those are some cool features. Anita, over to you.
Okay, so starting off with the many model solution accelerator, the way it's currently set up is that we expect you to bring in your data as file data sets. So let's just say you're training 10 models. We expect that you have your data split into 10 files. Now, in order to solve that problem, we want to make sure you could bring in your tabular data set. So as of Ignite, you could bring in one tabular data set, and we will automatically partition that for you based on the group columns that you specify. So for example, let's just say we're training an orange juice prediction scenario. We could partition that one tabular data set by store and brand, and it will automatically train the 10 or thousands or millions of models for you. And additionally, we did increase our scale. So last year we were at 100,000, but now we can train millions of models. So we've also added that in. And now looking at the auto ML space, couple things that we are currently in private preview with is code generation, and then where you could take your auto ML run from the UI and generate a notebook out of it. And we also did some forecasting enhancements. So on top of our many model solution accelerator, we have built hierarchy time series. So if you want to test that out as well, we do have a solution accelerator for that.
These are cool things, like just the fact that you can build tailored models, because these models, like I said, if you feed a bunch of data at them, they'll get really good at being generic. But your Florida store, it might be very different than your LA store. You might as well have a model for each with data from each location. Is that what you're getting at, Anita?
Exactly.
There you go. See, I learned something. Sharafuddin had a question. I've seen 4 days back Microsoft Mesh introduced. I want to become a developer in that. What should I learn in AI, ML, and other related tools in Microsoft? So what advice do you have for someone that's like, I'm all in for AI and machine learning? How should I start? And this goes to anybody, because we're taking a little break, because like I said, if you're watching Learn TV, your questions are way more important than mine. Friends, how should we get started in AI, ML, particularly with Microsoft?
So I can take a quick stab at this question.
Let's do it.
If you're just starting in the ML space, I recommend starting with automated ML or our designer tools. So both these tools help you quickly build a machine learning model. All you'll need to do is bring in your data set. So when you're using auto ML, what it does is it will automatically choose the hyperparameters, do all the featureization work, and then return that best model for you. And you could easily quickly start within our ML Studio. So we do have a UI for this. Or you could go ahead and try training your model on the designer, where you could drag and drop and set up a pipeline to train your models. So just when you're starting, you could do that. And we do have a bunch of sample notebooks for you where you can quickly go ahead, figure out how to train your models using AutoML, Hyperdrive, or just using a custom script. So all of that information is on our document site.
That is right. You're seeing aka.ms/devrel/AML. That shows you the new features as of Ignite, but it will point you to the documentation as well, which is our goal. I love AutoML. Even as a data scientist, if you're thinking AutoML is stealing a job, it's not. It's actually doing the boring bit so you don't have to. Everyone is always going to start. Look, with machine learning, everyone starts with some kind of linear thing, and then they do a decision tree or a logistic regression or something else. Why not let the computer do all the work for you and pretend that you did it?
I think also, just to add as well, Seth, we've got some certifications as well that people can take. Like there's a data science certification and an AI engineer certification. And those can be great ways to sort of start the journey, and there's sort of curated learning paths for those.
Fantastic. Absolutely. Thank you for that. Again, keep your questions coming. They are more important. Saudia, to you, what are you excited about from Ignite? And then maybe some features that people just don't know enough about.
Yep, sure. So what we announced at Ignite was the ability to run, training jobs, anything like TensorFlow, PyTorch, MPI jobs on Kubernetes. And we today, the way we see compute for machine learning is you've got unmanaged compute and you've got managed compute. What falls under managed compute is what we have today, which is AML compute clusters. That is our managed offering. This is for folks who don't want to learn anything about the infrastructure. They just want to come have APIs where they can deploy training jobs. I want to run my training job, run me for it and charge me for it. Then there is that large set of customers that we've seen over the years that have adopted Kubernetes over the last 3-4 years, and that's because they want to be cloud agnostic. AKS is the fastest growing service in the history of Azure. So we thought, why not extend machine learning on AKS and leverage Azure Arc for Kubernetes, where a customer can seamlessly run training jobs across Kubernetes, AKS or Arc. You bring your own infrastructure, you bring your own GKE cluster or EKS cluster, and you can uniformly run that. So we're taking a stab at that. Kubernetes is the new infrastructure, and we want to learn from customers what their other needs are. But the basic starting point is you can run training jobs uniformly across both. Does that answer the question?
It sure does. And Saudia underplays it a little bit. If you have your own infrastructure, Azure Arc empowers you to be able to use what you already got. Let's just say you already have a bunch of GPU-based machines in a Kubernetes cluster. Put Azure Arc on there, and AML can target it as a compute target, an unmanaged one on our side because you manage it, right? Which is
one more thing I forgot to add was, like, we've tried to keep the personas separated, the data scientist persona and the IT operator persona who configures the Kubernetes clusters for the data scientist. We've tried to make sure that the data scientist doesn't have to learn about Kubernetes. They can just, hey, there's extra GPUs here, go target. That's the whole thing.
And it is really cool. Like I said, it's really seamless to be able to do that kind of thing. I saw a demo of it earlier, and it was really cool. Marnoosh, to you.
We have released revamped interpretability and fairness toolkits and dashboards, specifically visualization dashboards within Azure Machine Learning SDK and Studio. So interactively, you can learn more about your model performance, your data set, your global or overall explanation, your local explanations. You can perform what-if analysis and other perturbations. You can choose what fairness metric and what groups you would like to investigate and look at the fairness insights of them. We also have integrated the interpretability revamped dashboard with AutoML, so you can generate interpretability insights not just for the winner model of AutoML, but also the other models that AutoML had trained. And we also released an open source toolkit on error analysis, which will be integrated within Azure Machine Learning in the upcoming months.
And it's cool stuff. Like one of the things that I always struggled with is I build these models, and like Marnoosh said, I go to booths and people be like, we don't even know what it's doing. And I'm like, we're computer scientists. You should know something about what's happening. And so these new error analysis tools are fantastic for weeding out, like, where is it making mistakes? Sam, to you.
I think my favorite one is the Synapse Spark integration that we've done, so that you can now access all the power of Spark that you might have at your Spark pools in Synapse. You can bring that into Azure ML and use the notebooking experience in Azure ML to attach to those and run interactive workloads, where you've got large data sets, but also being able to run jobs and things like that on Spark.
Yeah, and it's cool because it enables an additional compute target for those that are Spark heavy. For example, you can target, let's just say, for example, you want to do all of your feature stuff in Synapse. That's great, right? They can go both ways. I saw a question here that came up. By the way, they're telling me it's time to wrap, but there was one question about, can you use your own blob storage to do auto machine learning? Yes, in fact, it's a first-class citizen. All right. So it looks like we are getting ready to wrap. So I just want to finish up by saying thank you to all of you that were here. Thanks for joining us. Check out the link below to watch this and more episodes on demand, and find out what episodes are coming up soon. This has been an Ask the experts. We're super excited for Azure Machine Learning. These fine folks were here today this way. We're so thankful for everything you've done. And again, thanks for watching. And hopefully we'll see you next time.